spectrometer I1 I2 graph. The aim of our experiment is to draw the I1 I2 curve. I1 I2 curve means the I1 is the angle of incidence, and we want to determine the value of angle of emergence I2 for each value of I1. Then we are plotting a graph between I1 and I2, and using that graph we want to find the refractive index of the material of the given prism. For that we are provided with the spectrometer apparatus, and the given prism is here, and we are having a sodium vapor lamp. As you know, the spectrometer apparatus that consists of the telescope, the collimator, the prism table and the vernier table. For the adjustments of the spectrometer, initially the telescope is adjusted. For that we want to adjust the eyepiece first. We can pull in or pull out the eyepiece. Now we are focusing the telescope towards a white wall and looking through the eyepiece. The eyepiece is pull in or pull out so that the crosswire is clearly seen. Now for this particular position, the crosswire is clear. Now then the telescope is focused towards a distant object, and looking through the telescope we can adjust the rack and pinion arrangement of the telescope. We can vary the distance so that the distant object is clearly seen. Now for me, now the distant object is clearly seen. That means for that I adjusted this particular screw. Then for the collimator part, the telescope is focused on the collimator so that the collimator is illuminated by the sodium vapor lamp. The slit is illuminated, the light is coming through the collimator, and that ray is observed through the telescope. Now looking through the telescope, initially we can adjust the slit width using the particular screw attached to the slit, so that the slit is very narrow and clearly visible. Now we are getting a narrow slit there. Then we can adjust the length of the collimator. For that again there is a fine adjustment screw is here. We can adjust the screw such that the slit is again made narrow and thin slit is observed through the telescope. That is the adjustment of the telescope. Now the prism table can be raised or lowered and can be fixed at any height. That is a prism table. Then it is provided with a vernier table. Now the vernier table is graduated from 0 to 360 degree, and it is also provided two verniers, vernier 1 here and vernier 2 on the other side. And there are two verniers are there which are having readings from 0 to 30, and these two verniers are moving over the circular scale, and so we are having a reading. For a particular reading, the main scale reading is there and a corresponding vernier scale reading is there. So the total reading is main scale reading plus vernier scale reading into least count, where the least count is calculated using the formula value of one main scale division divided by number of divisions on the vernier. Now here for the given spectrometer, the value of one main scale division is 0.5 degree or 30 minutes, and number of divisions on the vernier is 30 divisions. So the least count is 30 minute divided by 30, that is equal to 1 minute. Now there are two screws are there for clamping the telescope. Now this is one of the screw. We can unscrew or loosen the screw so the telescope can be moved, and if it is tightened, then what happens that the telescope cannot be moved. So when we are taking the reading, we can tighten the telescope screw. So there is a fine adjustment screw is there for the telescope. Similarly, for the vernier also there are two screws we can see here. If this one is untightened, then we can move the vernier. Vernier can be rotated, and if this one is kept tightened, then what happens that the vernier is fixed. Now the vernier is fixed. Now for fine adjustments there is a fine adjustment screw is there. That is about the instrument part. Now let us see the theory of the experiment. Spectrometer I1 I2 curve Our aim is to draw the I1 I2 curve, where I1 is the angle of incidence and I2 the angle of emergence. Now for a prism, when the ray is deviated, we are having the equation, the deviation D is equal to I1 plus I2 minus A, where I1 is the angle of incidence and I2 the angle of emergence, and A is the angle of the prism. Now this is the condition that take place. I1 is the angle of incidence and I2 the angle of emergence, and D is the deviation. And here we are having two more angles, R1 and R2. R1 is the angle of emergence at the incidence side, and R2 is the angle of incidence at the second phase. And from the diagram we can see when the ID curve is plotted. Here we are not plotting the ID curve for the prism. For a particular value of I, there is a deviation D is there. So as the value of the angle of incidence increases, what happens that from this formula the deviation decreases, and when I further increased, what happens that the deviation again increases. So the graph between I and D for a prism is like this, a parabolic curve that shows that for a particular value of deviation, for example if we are taking a deviation D here, we can see there are two values of I. One corresponds to this particular point and the other one corresponds to this point. There are two values of I. But at the minimum deviation, that means when the deviation is minimum D, capital D, there is only one value of I, that is equal to I. That means at the minimum deviation, small d is equal to capital D, then I1 is equal to I2, that is equal to I. Or we can calculate, the earlier formula becomes D is equal to I plus I minus A, or I is equal to A plus D by 2. And again from the diagram we can see the angle R1 plus R2 plus N, that is equal to 180. Angle R1 plus R2 plus N is equal to 180. Also angle A, this is the angle A plus angle N, that is equal to 180. Now comparing these two equations, we can write R1 plus R2 is equal to A. And at the minimum deviation, R1 should be equal to R2 and that is equal to R. So R1 plus R2 equal to A becomes R plus R, that is 2R equal to A, or R equal to A by 2. Now using the Snell's law, mu is equal to sin I by sin R, we can calculate the refractive index sin I by sin A by 2, where A is the angle of the prism that we have to determine. Then I, we want to find out from the I1 I2 curve. Now for that we are plotting a curve like this. I1 is plotted along the x-axis and I2 is plotted along the y-axis. So this is our aim of the experiment, or the experimental part. For a particular value of I1, we want to determine I2 and then plot a curve. Then we are drawing the perpendicular, the bisector of the curve graph, that is a line which is making 45 degree with the x-axis and y-axis, that is cutting the I1 I2 curve at a particular point, say P. From that we are drawing the perpendiculars PA and PB. Then find the value of OA and OB. Then by the principle, angle I should be equal to OA plus OB by 2. So that is what we are doing in our experiment. We are plotting the graph, and from that graph we are finding the value of OA and OB. Then OA plus OB by 2 gives the value of I, the angle of the prism. Now using this value of I and the value of R, that is A by 2, we can calculate the value of mu, the refractive index of the material of the prism. Now coming to the procedure part, first we want to find the angle of the prism. Now for that, the prism is placed on the prism table. The light coming from the collimator is allowed to fall on both the two faces of the prism. For that, the edge of the prism is placed towards the collimator. Then the light is reflected from the face AC. Similarly, light is reflected from the face AB. Now moving the telescope, we are observing the light reflected from the face AC first. Then we are taking the readings of both vernier 1 and vernier 2. So the first reading is, we are taking, we are focusing on the reflected ray or the reflected image with the help of the telescope, the image from the face AC. Then we are taking the reading corresponds to vernier 1 and vernier 2. Then the telescope is moved to the other side and observing the image from the face AB. Then also we are taking the reading of vernier 1 and vernier 2. From that readings, we can calculate the angle of the prism. So this is the tabular column that we are using. Initially we are focusing on the reflected image from the face AB. Then Vernier 1 reading is here, Vernier 2 reading is here. Then we are focusing on the reflected image from the face, say AC, from the face AC. Then we are having that reading is marked as X2. Then also we are having the reading Vernier 1 and Vernier 2. Then the difference of these two readings, face AC and face AB, that is X2 difference of X1, that gives the value of 2A. That 2A can be calculated for Vernier 1 and similarly for Vernier 2. Then mean 2A is calculated and from that the angle of prism is determined. Now the second part, that is the setting the prism for a particular angle of incidence I, and then to determine the value of I2, that is the main part of the experiment. Now for that, initially the telescope is brought in a line with the collimator. So we are obtaining the slit image on the telescope. Then the telescope is fixed there. Now we can move the vernier table, we can move so that one of the vernier reads 0 and the other vernier reads 180. So that is the initial step. The telescope is focused or brought in a line with the collimator and the slit is falling side by side with the crosswire, vertical crosswire of the telescope. Then the vernier is rotated and clamped such that vernier 1 reads 0 and the vernier 2 reads 180. Now from that we want to arrange the prism for a particular angle of incidence. For example, we want to I is equal to 40 degree. Let I is equal to 40 degree. Then 2I should be equal to 80 degree. Then you can observe the diagram here. Now this is the collimator. Now this is the position of the telescope. So the total angle is 180 degree. 180 degree. Now here this I is 40 and the angular reflection is I, that is also 40. Therefore 2I is equal to 80. Now this angle should be 80 degree. Now the remaining angle should be equal to 180 minus 2I or 180 minus 80, that is 100. Now so we are calculating the value of 180 minus 2I. Now in this particular case, if we are taking I is equal to 40, 2I is 80 and this 180 minus 2I is 100. That means the telescope which is focused on the collimator and the slit, now the telescope is rotated through an angle of 100 degree, that is 180 minus 2I degree, and it is fixed here, that is the position T1. After that the prism is placed on the prism table and the prism table alone is rotated such that we are getting a reflected image. Now in the experimental part we will see that prism is placed, the prism table is rotated and we are getting a reflected image. Now the angle of incidence I is equal to 40 degree. Now if you want to change the angle of incidence to say another value, say 50 degree, then calculate the value of 2I, that is 2I is 100. Then 180 minus 2I is 80. Then we are placing the telescope at a position so that the vernier 0 reads now 80. It is rotated through 80 degree. 80. Then the prism is placed so that we are getting a reflected image on the prism in the telescope. Then the angle of incidence should be equal to 50. Similarly, we can arrange the prism at any angle of incidence by this particular method. Now going back, for the first case, if you want to find the angle of emergence, now for that we place the telescope here, we obtain the reflected image. Then we are coming back on the other side and we observe the deviated ray. We observe the deviated ray. So that is at the position T2. Then we are getting the deviated ray. Now again we are rotating the prism table. Remember, we are rotating the prism table such that this deviation is minimum. This deviation, now this is the angle of deviation D. This angle of deviation D is minimum. Now for that we can observe the refracted ray or deviated ray. That deviated ray moves towards the direct position. That means the angle is decreasing. And the image moves towards the direct position. At a particular position it stops there and it starts coming back. That is the minimum deviation. Now in this particular experiment, now you are supposed to continue the rotation such that the image moves towards the direct position, then coming back, and again back and coinciding with the crosswire of the telescope, coinciding with the crosswire of the telescope. That is why I marked here. Looking through the telescope, the present table alone with the prism is now rotated so that the deviated image moves towards the minimum deviation position in the direction of the direct ray, and then returns to the vertical crosswire, and then returns to the vertical crosswire. Now the vernier table is clamped. Now what happens that the angle of incidence should be changed. The angle of incidence changed, but the deviation is same before. Why we are saying the deviation same before means the ray goes to the direct position and then it is coming back and again coinciding with the crosswire. So we are not changing the position of the telescope. So the deviation will be the same, but the prism is already moved. The angle of incidence is changed. Now what happens that using this expression, the d value will be the same, then angle changed. So in order to satisfy this equation, that is d and a are constant, to satisfy this equation again, what happens that I1 and I2 interchanges. Now the value of I1 changes to I2. That means at present what is the angle of incidence, and that angle of incidence should be equal to I2. Remember, we rotated the prism, we already arranged for a particular value of I1, from that we rotated, and after rotation I value changes. Now the I value will be 2I. Now we want to determine that value of 2I, so that I2 value. Now for that the telescope is released from the position and we are going back. The telescope is brought to the position T1. The telescope is brought to the position T1. At this position we are taking the reading of vernier 1 and vernier 2. So that is the first reading that we are taking, and that image is said to be the second reflected image or second image, the second image, because initially we obtained a reflected image here. We are not taking the reading for that. After in the minimum deviation we are coming back and we are taking the reading, and that is a second image or second reflection. So that reading we are taking on the telescope T1 position, vernier 1 and vernier 2. Now the telescope is brought in a line with the direct image. We are observing the direct ray, direct image. So that reading corresponds to the direct image. Then this difference of these two readings, that gives 180 minus 2I2. Now it is I2, not I1. Now it is 180 minus 2I2. So we obtain the value of 180 minus 2I2, and from that I2 is determined. Now we can repeat the experiment. For that we select another value of I1 and the experiment is repeated, and then we obtain I2 for that I1. So for different values of I1 we obtain the different values of I2, then we can plot a graph, I1 I2 curve. So coming to the table column that we used here, we can see initially, for example, if you are taking the angle of incidence is 35, then the angle through which the telescope is rotated, that is 180 minus 2I. Now we are not taking reading there. We obtain the reflected image, coming back observe the refracted image, bring it to the minimum deviation position and coincide with the crosswire of the telescope. Then telescope is moved once again to the other side and the reflected ray is observed, corresponds to the angle of incidence I2. Then we are taking the vernier 1 reading and vernier 2 reading. After that we are taking the reading corresponds to the direct ray, that is after the second reflection, again vernier 1 and vernier 2. Then vernier first reading corresponds to the reflected ray is marked as A, and the direct reading is marked as B. Then A difference of B gives theta 2. Now we are getting 2 A difference of B, one is for vernier 1 and the other one is vernier 2. Now mean of these two is calculated, that is mean theta, and from this theta or theta 2 we can calculate I2 using the formula 180 minus theta 2 by 2, that is the value of I2. So we obtain I2. So we fix the value of I1 that we selected, I1 is 35, we obtain the value of I2. Then again the experiment is repeated for another value of I1, that is 40, and for that 40 we obtain the I2 value. Then using that I1 and I2 we plot the curve, the earlier curve, I1 I2 curve is plotted. Now this curve is plotted. Then we are getting a curve like this. From that, the point P is located, OA and OB are determined, and using OA and OB, I is determined, and using that value of I and the angle of the prism, we can determine the refractive index mu of the material of the prism can be determined. So this is the formula for the calculation. Mu is equal to sin I by sin A by 2, I is equal to OA plus OB by 2, and A is we determine the angle of the prism, then mu is equal to sin I by sin A by 2. Now let us see how we can determine or how we can find out the angle of emergence I2 for each value of I1. So this spectrometer is already arranged. We have seen all the arrangements. Now looking through the telescope, we are observing through the collimator and we obtain the image there. The slit is there. Now the slit is coinciding with the crosswire of the telescope. Now we can rotate. Now the telescope is fixed there. Now the vernier table can be rotated. Now this we are rotating the vernier table. There is then no change for the telescope position. The telescope remains there itself. So the vernier is rotated so that now this will be vernier 1 and here this will be vernier 2. Now the vernier 1 is reading 0 now. Exactly the 0 of the vernier is coinciding with the 0 of the main scale. So here vernier 1 reads 0. Then here vernier 2 reads 180. At this particular position, this vernier table is clamped. Now the vernier table is clamped. Now the vernier table is clamped, so it cannot be rotated. It is not movable. Now we want to place this prism over the prism table, and we are selecting a particular value of angle of incidence. Say let angle of incidence I is equal to 40 degree. Now how we can arrange the prism for an angle of 40 degree, that we are going to see first. How we can arrange the angle of the prism for a particular angle of incidence. Now here for an example, the angle of incidence I is equal to 40 degree. Now for that the prism is placed over the prism table like this. The prism is placed. The light incident on one of the face, say AB face, AB face. Now we can see that the telescope is in a line with the collimator. So the angle between the telescope and the collimator, now this angle is 180 degree. Now I am selecting an angle I is equal to 40 degree, then angle of incidence is equal to 40 degree, and if it is reflected, angle of reflection is also equal to 40 degree, then 2I, that is equal to 80 degree. So if we bring the telescope in a position, that is the angle between the collimator and the telescope is 80. For that, now this total angle is 180 degree. For that we have to rotate the telescope through an angle 180 minus 2I. Here 2I is 2 into 40, that is 80. 180 minus 80, that means 100 degree. That means this telescope, telescope is to move through an angle of 100 degree. So for that we can unclamp the telescope here. Now we can rotate the telescope. Now the telescope is rotated. Then how we determine it is 100 degree, that we can take the reading over the vernier. Initially the vernier is reading 0. Now the reading is increasing. Now when the reading becomes 100 degree here, we can fix the telescope at that particular position. Now it is 90, and now again we are moving. Now now the 0 of the vernier is coincident with exactly 100. Now here in vernier 1, 0 coinciding with the division 100, that means the telescope is turned through an angle of 100 degree, and the vernier 2 is reading 180. Initially it is reading 180, now it is reading 280. It is reading 280. Now at this particular position the telescope is clamped. The telescope is clamped. Now we cannot move the telescope also. The telescope is clamped. Now you can see here this angle is 100 degree. Now this one is 80 degree. 80 means 2I. So I is equal to 40. 40 plus 40. Now we have placed the prism here, and we can rotate the prism table. We can rotate like this. Light incident on the prism table, and the light is reflected. We can arrange the height also. Height also we can arrange. The light incident here, and the light is reflected. Now we have to obtain the reflected ray in the telescope. For that we are rotating the prism table. We can rotate the prism table. and observe through the telescope to obtain the present table. That we want to do. Now I am observing through the telescope. I want to get the reflected ray. Now for that, the present table is rotated. Now I am getting the reflected ray. Now rotate this present table such that slit, the image of the slit should coincide with the crosswire. Now I am getting the image. Now the image is coinciding with the crosswire, vertical crosswire of the telescope. Now this angle is totally 80 degree, incident ray is there, reflected ray is there. So the angle of incidence is I is equal to 40 degree. Now at this position, unclamp the telescope and bring to the other side. Bring to the other side and observe the deviated or the refracted ray. We want to observe the deviated or refracted ray. Now observe the deviated ray. Now I am getting the deviated ray. The deviated ray is observed on the other face, AC. Now again, we are rotating the present table. Now the present table is rotated, then the angle is going to change. Now we want to bring the deviated ray in the minimum deviation position. Now looking through the telescope, the present table is rotated. Now I am rotating the clockwise direction. Now what happens that the image is moving to the right side, that is towards the direct position. The image is moving to the direct position. Now again it is moving. Now the image stops there. Image is remaining stationary. Now I am not fixing here. Remember, continue the rotation again so that now the image is coming back. Now the image is coming back. Again it is coinciding with the crosswire. So that is a condition in I1, I2 curve. Rotate the present table such that image moves towards the direct position, remain stationary, continue the rotation till the image again coincides with the telescope. Now there is no change in the angle of deviation. The deviation should be the same because the telescope is fixed. Now at this position, clamp the present table, and also the vernier table is already clamped. Now we can unscrew the telescope, the unscrew. Now we are moving the telescope to the other side again to observe the reflected image, because the angle, here the angle is changed. The I1 is changed to a value of I2. I1 is changed to a value of I2. The angle of incidence is changed. So we are moving to the other side and we are observing again the reflected image from the other side. Now observe the reflected image. Now observe the reflected image. Now the reflected image is there. There is no need of taking the reading. No need of taking the reading. Now we can take the reading now. Now reading corresponds to this reflected image. Now for that, the telescope is made, the crosswire is made to coincide with the image. Now the crosswire is coinciding with the image. Now I can take the reading of vernier 1 and vernier 2. Now here in vernier 1, I am taking the reading. Here in vernier 1, the reading is 79 degree. The reading of the vernier 1, sorry, not 79, the reading of the vernier 1 is 258 degree 40 minute. 258 degree 30 minute and 18 division is coinciding. So the total reading is 258 degree 40 minute. Then in the vernier 2, the reading is 79 degree and the 30th division, actually 79 degree 79.5. So that is 79 degree 30 minutes. So that is not it. Now we are bringing the telescope back to observe the direct reading, because now this is 2i, that is 2i2 actually, 2i2. Now 180 minus 2i2, that is our theta 2. It is bringing back to observe the direct reading. For that we can remove the prism. If you are not removing, then also we can observe the direct reading. Anyway, we are removing the prism. Then we are observing the direct reading. Then we are observing the direct reading. The direct image is there. Now again coinciding with the crosswire. Then take the reading of vernier 1 and take the reading of vernier 2. In vernier 1, the reading is 201 degree, and in vernier 2, the reading is 21 degree. So in vernier 1 201 degree and in vernier 2 it is 21 degree. So that we completed. So using that readings we can determine the value of I2 for the value of I1, that is equal to 40 degree. Now we want to repeat it again. Now we select another value of I, say I is equal to 45 degree. Then again we are going back, we are rotating the present vernier table such that one of the reading is 0 here and the other reading is 180. Now looking through the telescope, it is made coinciding with the crosswire, that is coinciding. Now the vernier table is clamped. Now we are rotating the telescope through an angle. Now we are deciding the angle because I is equal to 45 degree. Then 2I, that is 2 into 45, that is 90. 180 minus 90, that is 90. So the telescope is rotated through 90 degree. So it is rotated. Now at 90 we are fixing the telescope. Now the telescope is fixed here. Now it is clamped. Now we are placing the prism over the prism table. The prism is placed over the prism table so that light incident on one face. We can rotate the prism table like this. Then light incident here and the light is reflected. Now rotating the prism table like this, observe the image through the telescope. Now I am getting an image here. That image is now coinciding with the crosswire of the telescope. Now the angle of incidence is 45 degree here. Now the prism is set for an angle of incidence 45 degree. Now we can unclamp the telescope. The telescope is unclamped and it is brought in the other side to observe the refracted ray. Now we can observe the refracted ray on the other side. Now here I am getting the refracted ray. Now we want to bring it in the minimum deviation. For that we are rotating the prism table. The prism table we are rotating. Now we are rotating the prism table. Now the image is moving towards the right side. It is moving towards the right side. It is going to the right. Now it remains there stationary. Now it is coming back. Now allow it to come back and coincide with the crosswire. Now it is coming back and coinciding with the crosswire. Now the D will be same. D is not changed. So for the same value of D, what happens that the earlier I1, that means our 45 degree I1 changed now because it is rotated. Now we are getting a new value of I, that is actually I2. So to obtain that I2, we are going back on the other side and observe the image. Now I am getting the image here. Now make the crosswire of the telescope to coincide. Now it is coinciding. Now we have to take the reading corresponding to this particular position. Now in vernier 1, we are getting a reading of 249.5 and the 10th division is coinciding. So the total reading is it is not 249, 259. 259 degree 40 minute, and in the vernier 2, 80 degree and the 5th division is coinciding. So the total reading is 80 degree 5 minute. 80 degree 5 minute. Then we want to take the reading corresponds to the direct ray. For that, the telescope is brought in a line with the direct ray. Now looking through the prism itself, there is no need to remove the prism. You can obtain the direct ray. Now I am getting the direct ray. Now corresponding to the direct ray, the reading is the reading B. In vernier 1, the reading is 189 degree 189.5 plus 10th division is coinciding. So 189 degree 40 minute, and in vernier 2 the reading is 9.5 degree, that is 9 degree 30 minutes. 9 degree 30 minutes. So now I completed for the angle of incidence I is equal to 45 degree. Now we can repeat it for angle of incidence 50 degree, 55 degree, 60 degree. We can repeat the experiment and we can obtain the readings. And using that readings, the readings are tabulated. Using that readings, we can calculate the value of I2 for each value of I1, and the I1 I2 graph can be plotted. Now coming to a sample set of reading, we have already mentioned the value of one main scale division is 30 minutes and number of divisions on the vernier is 30. So the least count is 1 minute. When we are finding the angle of the prism, I obtain when we observe the reflected image from the face AB. Vernier 1 and Vernier 2 readings are here. Vernier 1 reading is 123 degree 10 minutes and Vernier 2 reading is 303 10 minutes. Then the telescope is focused on the face AC. Then Vernier 1 reading is 243 45 minutes and Vernier 2 reading is 63 degree 40 minute. So this 63 degree 40 minute is actually 360 plus 63, that is 423 degree 40 minute. Then we can calculate the difference to A. Vernier 1 means the difference of 243 and 123, that is 120, and in Vernier 2 the difference is 423 degree 40 minute and 303 degree 10 minute, that is again 120 degree 30 minute. So the mean of these two, that is 120 degree 30 minute, that is 2A. From that A is equal to 60 degree 50 minutes. Then for the second part, now initially we want to arrange, we selected a angle of incidence I is equal to 35 degree. Then the telescope is rotated through an angle of 110 degree because 2I is equal to 70, 180 minus 70, that is 110. So the telescope is rotated through 110 degree. Then we obtain a reflected ray. We are not taking the reading there. We are going back to see the refracted ray, bringing it to the minimum deviation, and then going back to see the reflected ray from the face. Then we are taking the reading, that is the reading A. Then we obtain the readings 255 degree 30 minutes in Vernier 1 and 75 degree 55 minutes in Vernier 2. Now the telescope is unclamped and brought to observe the direct image. Then the readings in Vernier 1 is 214 degree 5 minutes and in Vernier 2 34 degree 10 minutes. Then we can find the difference, A difference of B. This is A and this one is B. A difference of B. For Vernier 1 we can see Vernier 1 255 degree 30 minute, difference of 214 degree 5 minutes, that is equal to 41 degree 25 minutes. Similarly in Vernier 2 75 degree 55 minute minus 34 degree 10 minutes, that is again 41 degree 45 minutes. The mean of these two is 41 degree 35 minutes. Now it is repeated for another value of angle of incidence. Say angle of incidence is equal to 40 degree we selected. Then theta through which the telescope is rotated, that is 180 minus 2I. 2I is 80. So 180 minus 2I, that is 100. It is rotated through an angle of 100 degree and fixed. Then we obtain the reflected ray by placing the prism. Prism is rotated and obtain the reflected ray. We are not taking reading. We are coming back to the other side. Refracted ray we observe. Bring the refracted ray to the minimum deviation position and then again rotate to coincide with the cross wire. Then we are going back to the other side once again. The reflected ray is observed again. Now the angle of incidence should be equal to I2 we mentioned. Then the Vernier 1 and Vernier 2 readings are here, 258 degree 40 minute and 79 degree 5 minute. That is Vernier 1 and Vernier 2 and that is A. Then again we are taking the direct reading, that is the reading B. Vernier 1 201 and Vernier 2 that is 21. Then we are finding A difference of B of Vernier 1, that is 258 degree 40 minute minus 201 degree, that is equal to 57 degree 40 minute. Similarly 79 degree 5 minute minus 21 degree, that is 58 degree 5 minute, that is 57 degree 52 minute. Similarly we are changing the value of I to 45 degree, 50 degree, 55 degree, 60 degree. For each case we obtain the I2 value. Now initially 45, 41 for 35, 57 that is for 40, for 45 we obtain that is 70, for 50 we obtain 81, for 55 degree we obtain 89 degree 32 minute and for 60 degree we obtain 95 degree. Then we plotted a graph here. Now this is the graph plotted. The I value 35, 40, 45, 45, 50, 55. The corresponding value of I2 is plotted here. That is 40, 45 is marked here. The I2 value is plotted. Then we obtain the I1, I2 curve. I1, I2 curve is obtained. Then we are drawing the bisector at 45 degree. by setting the x-axis and y-axis. Now we obtain the position P here. From P we obtain A, that is OA we can obtain here. Now OA is about 49 degree. Similarly OB is also 49 degree. Now using that value of OA and OB, OA plus OB by 2, we obtain the mean value of I we obtain. Angle already we obtained, that is 60 degree. Now we calculate the value of mu sin A by 2, we obtain 1.524 as the refractive index of the material of the prism.